Okay, class, so today in class we'll be going over the dot problem. The dot problem addresses several of the standards for mathematical practice, including SMP1, make sense of problems and persevere in solving them. SMP number 3, construct viable arguments and critique the reasoning of others. SMP number 4, model with mathematics. And SMP number 7, look for and make use of structure. So the dot problem starts this way. We're given a pattern of dots that increases the number of dots in every stage. We want to know how many dots will be in the 20th stage. One way we could go about this is by writing out and following the pattern all the way through 20 stages of dots. That's going to take all day. So what we want to try to do is form an equation or something that can show us how many dots are added to each stage. So here we've constructed a table that shows the stage number and then the number of dots for that stage. So if we go back and look at the number of dots on each stage, we should be able to fill in this chart. So the first stage, as you can see, has 2 dots. The second stage has 6 dots. The third stage has 12 dots. From here, we just try to look for a pattern or see if there's anything we can find. One thing that might be able to help is if we find the 4th stage. So to find the 4th stage, let's try to find a pattern through the first 3 stages to see if we can create the 4th stage. If you look at the first stage, there's just one row of 2 dots. Moving over to the second stage, it looks like there's a row added across the top and a column on the left side. Going on to stage 3, stage 2 is right here, and it adds a row across and a column down. So let's do that again for stage 4. Let's draw stage 3. So right here we have stage 3. To make it into the next stage, let's add a row across the top and a column down. And that's stage 4. Alright, since we were able to create the 4th stage, we know that the 4th stage has 20 dots in it. From here we can look at this chart and try to see if we notice any patterns. One thing that I see is that 1 goes to 2, 2 goes to 6, 3 goes to 12, and 4 goes to 20. I know that 1 times 2 is equal to 2. 2 times 3 is equal to 6. 3 times 4 is equal to 12, and 4 times 5 is equal to 20. From this, we can see that it looks like the stage number times the stage number plus 1 will give you the number of dots in each stage. So we can write that this way. Since we were able to figure out the pattern, we can write it out as an expression. So we said that the pattern is x, which is the stage number, times x plus 1, which is the stage number plus 1, will give you the number of dots. So we determined the equation to find the total number of dots to be x times the quantity of x plus 1 to equal n, where x is the stage number and n is the total number of dots. So we can rewrite this equation by distributing x to get the equation equal to x squared plus x. The original problem was to solve for the 20th stage, so we can do 20 squared plus 20 is equal to n, which is the total number of dots. So in the end, we get 400 plus 20 equals 420, which is the total number of dots for the 20th stage.